Now we continue our study on the characteristics of the nerve message or action potential. You know that the second our objective was to study the characteristics of the nervous message in a nerve fiber and in a nerve. As you remember, look to this. These are our objectives. These were our objectives. One, nervous message and action potential. Study the characteristics of nervous message in a nerve fiber and in a nerve by interpreting experiments, and we will draw conclusions. We finished our study on nerve fiber, the characteristics of nervous message in a nerve fiber. Now in a nerve. But first, in order to study the characteristics of the nervous message in a nerve, study of the characteristics of nervous message in a nerve, the main idea first is to know what is a nerve. We know what is a nerve fiber, but what about the nerve? A nerve, what? Look to this. A nerve is a heterogeneous group of nerve fibers. A nerve is a group, many heterogeneous nerve fibers. What does this mean? What is the meaning of this? In reality, look to the nerve. It is a group. It is a bundle of, a group of fibers. So a nerve fiber, in general, that is an axon in general. I said before, maybe it is a dendrite, but suppose it's an axon. So it is in one axon. But when I speak about the nerve, a nerve, what? A nerve is a group of nerve fibers, group of axons, group of nerve fibers. So what is a nerve? A nerve is a group of nerve fibers that are not homogeneous, that are what? Heterogeneous. Are the nerve fibers in a nerve? No, yes, it is. Non homogeneous, non identical. They are heterogeneous. They are different. How many types of nerve fibers? We have many types. Sheathless, with myelin sheath, with span sheath, with two sheaths, high diameter, low diameter, etc., etc. So look to this document. Here we have a myelinated nerve fiber with myelin sheath. Here we have non-myelinated nerve fiber. Look to this fiber. It is thin fiber, thin, very thin, having a very small diameter. But this one has greater, larger diameter, okay, bigger diameter. So the fibers inside the nerve are not alike, are not identical, are not homogeneous. For this we say what? A nerve is a group of heterogeneous, different nerve fibers. What does this mean? Does this mean only that are not identical by the shape? No. It will mean many than this. It means they do not have the same threshold, and they will not transport the action potential with the same speed. Same speed. مش speed, speed. So a nerve is a group of heterogeneous nerve fibers. What does this mean? ما عندهم نفس الشكل بس أساس؟ لا. They do not have the same shape, the same external يعني, aspect, but it means also that they do not have the same minimal intensity or threshold intensity. Some will work at 3 amperes. The others will work on 1 ampere, etc., etc., etc. And also, when we have an action potential, they will not have the same velocity of the nervous message. They will not conduct, they will not transport the nervous message with the same speed or same velocity. It is very important to know this, because this will change the characteristics. It is not a nerve. It is a group of heterogeneous nerve fibers. Type good. Now let us continue. What does the speed depend on? What are the factors that affect the velocity of the transportation of the nervous message? In reality, the speed or velocity of nervous message depends on 3 factors. The velocity of propagation, increases with the velocity or the speed of propagation of the nervous message or of the action potential increases with what? The presence of myelin sheath. So if there is myelin sheath, the speed or the velocity is greater than a nerve fiber that is without myelin sheath, because we said that the velocity of propagation increases with the presence. If myelin sheath exists, this will increase the velocity of the propagation, and it will increase with the increase in temperature. Yani suppose we have two fibers that are identical, but one of them is at 30 degrees centigrade, the second on 37 degrees centigrade. That existing on 37 degrees centigrade will transport more rapidly. The velocity in it of the action potential will be greater than, okay, the velocity that for that existing on 30 degrees centigrade. We only take one factor that changes between two fibers. And I cannot take one fiber with myelin at 30 and one fiber without myelin at 40. I cannot compare like this. I have to observe only the difference in one factor each time. Yani, two fibers, both with myelin sheath, one of them at 30, the second at 40. Yes, I can judge. I can tell you that existing at 40 is faster. Two fibers, another example, two fibers without sheath, one at 20, the second at 24. Yes, I will tell you that existing at 24 degrees centigrade is faster, will transport the message faster than that existing on lower temperature. We cannot take two factors. Yani. The third factor, we cannot take two factors at the same time. The third factor, the increase in diameter of the nerve fiber. If the diameter is bigger, the speed is faster. You know how? So the velocity increases with what? With the presence of myelin, with the increase in temperature, and with the increase of diameter. And if you have two fibers, one thin and one of larger diameter, existing on the same temperature, that having larger diameter will conduct will transport the message faster than that is thinner. Okay? So the velocity depends on three factors. When the fiber has myelin, it is faster. When it is on greater temperature, it is faster. And when it has bigger diameter, it is faster. Good. Now it's time to see something about the experimental study. In order to study based on what we saw about the structure of a nerve, please pay attention in order to understand what I will explain later. Based on what we saw about the structure of a nerve, I will give you a nerve. Look to this nerve. This is a nerve that is made. I will suppose this nerve contains 100 nerve fibers, such that suppose we have a nerve fiber. Sorry for this. A nerve, not verb. A nerve made of 100 nerve fibers. Yes, the nerve is made of many nerve fibers. Yes, of course. So let me do this. Based on what we saw about the structure of a nerve, I will suppose that we have a nerve. Yes, it's good like this. A nerve made of 100 nerve fibers, such that in this nerve there are 100 nerve fibers, but such that 25 nerve fibers of these 100 have a threshold of 0.5 milliampere. Yes, we said before, they do not have the same threshold, isn't it? Look to this. Okay? Look to this, please. Okay? A nerve is a group of heterogeneous nerve fibers that do not have the same threshold or same minimal intensity. Yes, I am giving you an example about that. So, suppose 25 nerve fibers have a threshold of 0.5 milliampere. Yani these 25 nerve fibers will not work except if the intensity of the stimulation is equal or greater than 0.5 milliampere. The other 35 nerve fibers have a threshold of 1.2 milliamperes, and 40 nerve fibers have a threshold of 1.7 milliamperes. So there are three different groups of nerve fibers in this nerve. Okay, Hubbi? So 25 plus 35 plus 40 equals 100. These are the 100 nerve fibers that are heterogeneous, are not all identical. Some of them have a threshold of 0.5, the others 1.2, the others 1.7. Now what? I will stimulate this nerve. Now I will stimulate this nerve. Please, many stimulations of increasing intensity are now applied on this nerve. Stay with me, please. Suppose I will stimulate I1, let's say with 0.4 milliampere. Are any fibers stimulated يا حبي? Are any fibers activated يا عمري? No, استاذ لا، لأنه 0.4 is not equal to any threshold of any fiber. It is less than the lowest intensity needed for fibers to be stimulated. So 0.4 milliampere will not stimulate any of these fibers. So none of the fibers is activated and no action potential is obtained. صافا يا عمري؟ إيه مليح. Now, if I increase the intensity of stimulation, it is now, look to this, it is 0.5 milliampere. How many fibers are stimulated? 0.5 will only stimulate these fibers, 25 nerve fibers. The 35 fibers and 40 are needing what? They need more than 0.5 milliampere. So, if I stimulate this nerve with 0.5 milliampere, 25 nerve fibers are activated and there is an action potential of amplitude A1. Okay? Then what if now I increase the intensity? What if I stimulate with 1.2 milliampere? How many fibers are stimulated? 35 يا أستاذ. وشو كمان؟ with 25 also يا أستاذ. لأنه these 25 nerve fibers start to be stimulated or activated starting from 0.5 milliampere and above. So if I stimulate now with 1.2 milliamperes, these fibers, these two groups will be stimulated. يعني 60, 25 plus 35 are stimulated. 60 nerve fibers are stimulated or are activated, and the action potential obtained has another amplitude that is greater than the first one. Why? Because the number of fibers stimulated or giving an action potential increased. Do you remember the nerve fiber? In the nerve fiber obeys the law of all or none. If we increase the intensity of stimulation for the nerve fiber, the one nerve fiber, the amplitude will not increase. Why? لأنه دائما هي one nerve fiber، مش راح تصير two nerve fibers. We are stimulating there, and the nerve fiber, we are stimulating only one nerve fiber. But here, or we increase the intensity of stimulation, the number of nerve fibers activated increases, وكل nerve fiber بتعطي 100 milliampere. So, if the number of nerve fibers as here, look, for 1.2 milliamperes, the number of activated nerve fibers is 60. But it was what? It was 25 when we stimulated with 0.5 milliampere. So, when the number of activated or stimulated nerve fibers increases, طبعا الاكشن potential will increase. إذا عملت stimulation ل 1 nerve fiber بيطلع عندك 70 ملي فولت. طيب 2 nerve fibers 70 زائد 70 140 ملي فولت. So when the number of nerve fibers increases, the amplitude of the action potential of course will increase. مثل بطاريات، إذا كان عندك بطاريات صغيرة، بطارية واحدة 1.5 ملي فولت، 2 batteries 3 volts، 3 batteries 4.5 volts etc. بس لما يكون عندك 1 nerve fiber حتى لو زدت الانتنسيتي اوف stimulation بتضل 1 nerve fiber بتضل تعطي بس 100 ملي فولت اللي هو ال value of the action potential for one nerve fiber. Now what if I increase the intensity of stimulation till 1.7 milliampere? If I stimulate with 1.7 milliampere, this group will be stimulated, this group will be stimulated also, and these 40 will be stimulated. And the number of fibers stimulated now will be 100 nerve fibers. Now what? If I4 is equal to 1.7, 100 nerve fibers are activated, so action potential of amplitude A3 greater than A2. طيب, what if I stimulate with 2 amperes now? How many fibers will be activated if I stimulate this nerve with 2 amperes? استاذ كلهم يعني قد ايه؟ 100. مش راح يزيدوا عدد الفايبرز. So if I stimulate now with 2 milliamperes, for example, the 100 nerve fibers stimulated with 1.7 will be stimulated also here. So action potential is A4 equals what? To what? Is equal to, sorry, equal to what? To F3. Come on. So if I simulate with 2 milliamperes, I5 equals 2 milliamperes, yes. All these fibers, the same number, 100 nerve fibers will be activated. So we'll obtain an action potential that will not increase anymore. Will not increase anymore. Why? Because with 1.7 milliamperes, all the fibers were activated. All the fibers were activated, and we obtained an amplitude A3. So this amplitude, where all the fibers were activated, will not increase anymore, because even if we increase the intensity of stimulation, the same number of nerve fibers is stimulated 100. So we'll obtain another, the A4, that is equal to A3. The amplitude will not increase anymore, because all the fibers were stimulated with 1.7 milliampere. And 1.7 milliampere will be called the maximal intensity of the nerve. Why maximal intensity? Because it will activate the maximal number of nerve fibers constituting this nerve. Yani all the nerve fibers that are constituting this nerve are stimulated, are activated with 1.7 milliampere. So 1.7 milliampere is called maximal intensity of the stimulation of the nerve. So when we increase the intensity above the maximal, same number of nerve fibers is stimulated, so we'll obtain the same amplitude. It is important, ya hubbi. Now what? As a result, we can draw that in a nerve, more we increase the intensity of stimulation, more the number of activated nerve fibers increases. I repeat, please. As a result, we can draw that in a nerve, more we increase the intensity of stimulation, okay, more the number of activated nerve fibers increases, as we saw in the experiment. Then what? And thus, more the amplitude of the action potential obtained increase. Yes, we say that the nerve obeys summation law. Summation, we are adding the number of nerve fibers activated. With I2, only 25. With I3, 25 plus 37. Summation, we say that the nerve fiber obeys what? To law of all or none. But the nerve obeys summation law. Till what? Is the amplitude of action potential increased forever? No, yes, it is. La. Till all nerve fibers are stimulated. In this case, the amplitude of action potential remains constant. So when all the nerve fibers with I4 are stimulated, the amplitude will not increase anymore with I5, even we increase the intensity of the stimulation. In this nerve, I2 is the minimal intensity of the nerve, and I2 is the minimal intensity, the first intensity activating nerve fibers, and I4 is its maximal intensity. I4 is the maximal where all the nerve fibers were stimulated or activated. In this nerve, I2 is the minimal intensity of the nerve, and I4 is its maximal intensity. Is there any question? Good. I want you to see something. Okay. I want you to see this. It is about the simulating the nerve and observation of what you will see on the oscilloscope. What I explained here is sufficient for you, but it is better to see the experiment itself for 1 or 2 minutes. What is important is, look to this. We have a nerve. Look to this. This is a nerve. The nerve is made of many nerve fibers inside. It is a bundle of nerve fibers. The nerve is a group of nerve fibers. Now what? And this is the oscilloscope. It is measuring a resting potential. Now what? I will stimulate low intensity, average intensity, high intensity, stronger intensity, maximal intensity, or very strong intensity. Okay? Low intensity, look to this. A ball is falling on the hand. Look to this. Okay? In reality, يعني كان أحسن لو إنه the first stimulation was not giving any action potential. But in this case, when I stimulate with low intensity, one fiber, look to this, only one fiber, this fiber, look to the light here. Okay, one fiber is stimulated, and you observe an action potential on the oscilloscope, of course. The lower indication, it is for the signal of stimulation. Look to this. Signal of stimulation, and above it, there is the action potential. It's not our objective. Our objective is to see when I increase, for example, the intensity of stimulation. Look to this. When I increase the intensity of stimulation, two fibers, more than one fiber were stimulated. You see? Look at this. And the action potentials will continue along the nerve fibers. Now I will increase the intensity also. All the fibers are what are stimulated. You see? It is a physical, it's the pressure now, a physical stimulation. More we increase the weight of the ball, more the intensity is greater, so more we observe, more nerve fibers are stimulated. But here, all the fibers are stimulated, so even if I increase now the intensity of stimulation, the same result is obtained, the same result. So because here all the fibers, as you see, when it is high intensity, force means high intensity, strong intensity, all the fibers, as you see, are stimulated. So now, even if we increase the intensity of stimulation, no more fibers will be stimulated, so the same result. And look to the, now I want you to pay attention for the amplitude of the action potential, please. There is an action potential of a given amplitude. We increase the intensity, the amplitude increased. Do you see it? The amplitude increased. We increase the intensity, also the amplitude increased again. But here, in this case, with a strong stimulation, all the fibers are stimulated. So even if I increase the intensity again, I will obtain the same result because all the fibers were stimulated with the strong stimulation. Good. Let us go to the experiments of the book. As we made for the nerve fiber, exactly as we made for the nerve fiber, we will now give 6 stimulations for the nerve. It is the same experiment, but now we are stimulating 6 times the nerve with increasing intensities. I2 greater than I1, I3 greater than I2, I4 greater than I3, and we are observing the result on the oscilloscope. Look to this. I will take the first 2 together. Why yes this? Because the first 2 stimulations did not give any action potential. Then I will take the others. Look to this, please. For stimulations of increasing intensity, I1 and I2, no action potential is obtained. So the intensity used is below the threshold. So in the blue color, the blue part of the answer is for the variable. The black part is for the result. And the red part is what? For, very good, for the relation or the significance. Because I want to interpret the experiment. Interpret means what? Means variable plus result plus significance, logical significance. Now I will continue, so I have to put what? A connector. So now I will continue. On the other hand, simulations with increasing intensity from I3 till I5. Increasing amplitude. Look at this. I cannot take I6 with them because I6 has the same amplitude. Now from I3 till I5, the amplitude is increasing. So same result. On the other hand, stimulations with increasing intensity from I3 to I5 provoke the appearance of action potential of increasing amplitude. So what? So the amplitude of the action potential in a nerve increases when the intensity of stimulation increases. Okay? Now, finally what? Finally what? Furthermore, a connector. Furthermore, for simulation with an intensity I6 greater than I5, what? We obtain an action potential of amplitude equals to that obtained with I5. I6, the intensity of I6 is greater than the intensity of I5, but we obtain the same amplitude of the action potential. So what? So with I5, ظاهر إنه with I5 all the nerve fibers of the nerve were stimulated or activated. Or we can say that, so I5 is the maximal intensity of this nerve, as I explained before. As a conclusion, then, can we say that then the nerve obeys the law of all or none? La, yeah, it says the nerve obeys what? Very good, the summation law. Then the nerve obeys to summation law. The number of fibers activated is increasing, is added every time we increase the intensity of stimulation, as we saw on the before, a few minutes later, on the experiment in a nerve having 100 fibers. Okay? Very good. So now the first important remark or characteristic is that the nerve obeys to summation law. طيب, what about the velocity? Please pay attention وحكوا لي شعركم لتفهموا أكثر. Okay? Now what? I will tell you a story. I will ask you a question in reality. I will ask you, please pay attention وخليني نشوف وتأكد انكم فعلا تلاميذ ذكية. I know that you are very smart students. Yes, I mean it. Okay. كان يا مكان في قديم الزمان كان في 3 cars making race كمان. So these 3 cars are making a race. And look to this. Look about the race will be with this velocity, these velocities. The violet or the purple car will have a of 90 kilometers per hour. The green one, 90.001 kilometers per hour. And this olive one, I think, or I don't know, olive oil is as oily one, or yellow car, yes, with a velocity of 98.999 kilometers per hour. And the race is for this distance. Look to this. Till here. يعني it is for a short, very short distance. My question is, which of these 3 will arrive first? Using our naked eyes, what car will arrive first? يا عمي ما أروعك. Very good. Using our naked eyes, we will not see the difference because they have approximately the same speed, and the race is for a very short distance. Look to this. Let us see, please. They arrived at the same time. Okay, again. We cannot distinguish which one arrived first. They arrive in same time. Both the 3 cars arrive in the same time because the distance was very short. At this short distance of race, this very low difference in speed is not detectable. Then what if the distance was greater, longer than this? What is this? Okay. Yes, I am surprised also, my cat. Yes, very good. So I am asking now, what if the race was for longer distance? Do not look to this cat, huh? Now, what if these 3 cars will make a race but for a longer distance? Look to this. Longer distance. Yes, if the distance is so long, very long, yes, this very low difference in speed will be detectable with the distance. Let us see now. Ah, yes, 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 yes. That's it. Yes, with a long distance, yes, this this negligible difference in velocities or in speed will be detectable. Yes, the green car having a velocity of 90.001 kilometer per hour. Okay, it will come first. Now we can detect that these three cars will not arrive together in the same time because the distance is longer. This is what I will use to explain the next idea. Please put this in your mind, and this information I will use to explain the next idea about the nerve. Okay? Very good. Let us see this document. Please. We have a nerve fiber. We have there, sorry, hundred thousands of times. So this is a nerve. This is what? A nerve. Stays نعم. What is the meaning of nerve? A nerve is a group of heterogeneous nerve fibers. يعني شو يا أستاذ؟ يعني the nerve fibers in this nerve will not transport with the same velocity the action potential when it is created. Okay? So when we will create action potentials by stimulating with strong stimulation, all the fibers are stimulated, all the fibers will give action potentials, and the action potential will propagate, but with not the same velocity. It's very important. Right. Here we have an oscilloscope. Look to this. The distance between S1, the stimulating electrode, S1, we'll stimulate with using S1, and R1, we will change it. Okay, S2 and R1, why not? Distance between S2 and R1. So we'll keep S1 on the axon. Every time we touch the axon with S2, these are the electric wires we are using of the adapter. We are using to give an electric strike, okay, electric stimulation. How can I give an electric stimulation for a nerve or nerve fiber? I will put one of the fibers, one of the wires on the axon, and every time I touch the fiber with the second axon, with the axon with the second fiber line or wire, I will stimulate it. Okay, so S1 is kept on the axon. The wire, electric wire, the second electric wire of the adapter, every time I touch the axon, the nerve, I touch the nerve with S2, so I stimulate it. And I will change now the distance between S2 and R1. In the first experiment, R1 was near, the oscilloscope was near to S2. Then I will increase the distance between S2 and the oscilloscope. I will take the oscilloscope away. Okay? What is the meaning of oscilloscope? It is the finish line of the propagation of the action potential. I will record with the oscilloscope the action potential when it arrives to the oscilloscope. So for the first experiment, the distance was 10 millimeter between S2 and R1, then 15 millimeter, 30 millimeter. We are increasing the distance between S2 here and R1. So the oscilloscope will be far now. Okay, please ya hubbi. Imagine that when you stimulate with a strong intensity the nerve, you will creating many action potentials that will propagate as the cars making a race here, as these cars making a race. They will propagate with different velocities. Okay? Now what? When the oscilloscope is near to the point of the starting point of the race, if you want, of the action potentials, because when we stimulate, we'll create action potential, and these action potentials will start to make a race. As a race, they will propagate along the axon. So when the axon was near to the S2, the race was for short distance. Look to this, as 15 millimeter, we observed only one action potential on the oscilloscope. But I want to ask you, is it only one action potential created here inside the nerve? لا. It says كان النيرف في بقلبه 100 fibers, you created 100 action potentials in every nerve fiber combination, and all the fibers are activated. Each fiber will give an action potential, and the action potential in each fiber will propagate. So, but because the oscilloscope was near to S2, all will come to the oscilloscope with the same time, approximately same time as for the first race, okay, for these cars, for the first race, okay? The finish line was what? The oscilloscope, as the oscilloscope was near to the starting point of the race. Now what? So, what? In the second time, we increase the distance between S2 and R1. It becomes double, 30 millimeter. when you take away, okay, you increase the distance between S2 and the oscilloscope, the race will take more time, and the distance of the race, the distance is greater. So the difference start to be observed. Look to this. One, we'll observe two action potentials, 1 and 2. What is the meaning of this? Yani this action potential comes first after approximately 0.1 millisecond. The second arrives approximately at 2 milliseconds. It means that there is a group of action potentials that are faster than the other group. When we increase the distance again, 70 millimeters, the difference becomes visible, more detectable. When the distance is 110 millimeters, yes, we observe this recording on the oscilloscope. What does this recording mean? It means that two groups of action potentials arrived. The first group arrived after 3 milliseconds of stimulation, and this is their amplitude. The second group comes after approximately 5.5 milliseconds. Yani a group of faster fibers and another group of slower fibers. So now the difference in velocities is detectable. Why? Because we are taking away the oscilloscope. We increase the distance between the oscilloscope or the starting point, the stimulation, and the recording oscilloscope. It becomes 110 millimeters is only. So this recording, as I said, proves the presence of two types of fibers. These fibers are faster because the action potential transported with these fibers arrived after 3 milliseconds only toward the oscilloscope, that is at a distance of 110 millimeters. And the second type of fibers is slower than the first one, and the action potential arrived approximately after 5.5 milliseconds of stimulation. And what about the number of fibers? Which group of fibers is greater in number? اللي عندهم more amplitude, يعني their number is more. Very good. So this nerve is made up of two types of fibers, fast and slow. These are the fast fibers, and these are the slow fibers. But the fast fibers are greater in number because they have the highest amplitudes. Okay? More the number of fibers increase, more the amplitude increases. We observed this before. So, as a result of this experiment, what? Two groups of nerve fibers constitute this nerve. One, a group of fast nerve fibers, and a group of slower nerve fibers. Remark, the number of rapid or fast fibers is greater than the number of slow fibers or of slow ones. This is about our study on the nerve. We studied before in part 1 the characteristics in a nerve fiber. In this part 2, we studied the characteristics of the nerve message or action potential in a nerve. And I hope you understand very well. I like you to study very well at home. And بإذن الله سبحانه وتعالى, next period, we will continue our study. There is one objective remaining about the propagation, about the type of propagation in a myelinated and non-myelinated nerve fibers. It is an easy idea, and not basic or essential in our program, but it's good to understand it. Hope you study. May God protect you and your family, and see you inshallah.